Hello children, how are you people doing? I'm Saurabh Kumar Dutt and I'm here to teach you people a little bit of mathematics. Now children, here we'll be discussing binomial theorem. For that matter, we will be looking up what an algebraic expression is, when it becomes a binomial, and when do we require the general expansion, that is the binomial theorem, and where all it can be applied. So gradually we will look up the different formulas which are linked with this chapter, and after that we'll also be looking up certain sums in detail, which will be sums of different types, so that you have a good grip of binomial theorem. So children, let's get started. Now whenever we talk about an algebraic expression, remember there are certain general algebraic expressions that you've studied. For that matter, if we talk about some ax plus by plus c, right, you know that this is an algebraic expression first. Then if you talk about a, b, c, they are the constants, right? And now children, if we talk about this x and y, they are actually your variables. So we have constants and variables which are either linked up by multiplication or division, and further by addition and subtraction, to form an algebraic expression. Right now children, we can have algebraic expressions which are of different forms. For that matter, here as you see, the highest power of the variable x is 1, and that of the variable y is also 1. As such, this algebraic expression will be said to be linear, or in other words, the degree of this algebraic expression will be 1. Now if you have an algebraic expression where the highest power of the variable is 2, then its degree will be 2, or in other words, it is also known as a quadratic algebraic expression. Now let's quickly have an example of such a sort of an expression. Let's say we talk about ax squared plus bx plus c. Now you know that this is the general quadratic expression where again a, b and c are constants, right? And if we talk about the x in x square or the x, they are actually the variables. Now since the highest power of the variable is 2, so as such we are going to call this to be quadratic, or in other words, the degree is going to be 2. So as the highest power of the variables are, thus we talk about the degrees. So as you see in the first case, we found that the degree of the variable was equal to 1. Here in this algebraic expression, you found that the algebraic expression has a degree of 2 because the highest power of the variable is 2. Now children, we come to what a term is. So if say we talk about a term is a very important facet when we talk about any algebraic expression. For that matter, whenever you have constants and variables which are multiplied together such that there is no plus or minus sign in between it, then we call it to be a term, right? So let's say now we talk about an algebraic expression which is say ax square bxc. So children, this will be said to be having one term, right? And as this is having one term, so as such it has a name which is known as monomial, right? And similarly children, if we now have another algebraic expression which is say slightly different as being ax squared plus bxc, now you've got to remember that this has two terms because there is one plus sign in between, right? So whenever there is a one plus or minus sign in between the variables and the constants which are mutually multiplied, then you will be saying that that algebraic expression has two terms, or in other words, it is a binomial, right? Similarly, if we go for 3, it is going to become a trinomial. Let's have a quick example for that matter. If suppose we talk about an algebraic expression which say is ax squared plus bx minus c. Now as you see that here we have two plus or minus signs, as such now we will be having 3 terms term, like I told you, is that algebraic expression which does not have a plus sign or a minus sign in between. As such, this forms to be a term, this forms to be another term, and this forms to be another term. So this is one term, this is another term, and this is the third term. As such, this has now three terms. Now, if we talk about such sort of an algebraic expression which has got three terms, then it is known as a trinomial. Now, more than three terms are there in algebraic expressions. Such sort of algebraic expressions are known as polynomials, right? So here, children, we now have a trinomial, a polynomial, a binomial, and a monomial. But remember, we would primarily focus when we talk about binomials. Now, I'm sure you people must have seen certain binomials, right? Like suppose if we talk about some x plus a, right, which is raised to the power 2, right? I'm sure you must have seen such a sort of a binomial. In fact, this is a binomial expansion which gives you the square of the first term as x square. To that is added the square of the second term, which is a square, and to that is added 2 times the product of the first term x with the second term a, right? So this is what you already studied in probably class 8 or 9. Now, we also have studied another formula which is similar. That is, if you talk about, say, some x plus a which is raised to the power 3. So this is another formula that you've learned. That is, you have the first term cubed, to which you have added the second term cube, and to that is added 3 times the product of the first term with the second term multiplied with the sum of the first term and the second term, right? So this is what you already studied. What if we now want to find out, say, some x plus a which is raised to the power 7? Do you have a value of this? No. And that is the reason why we study this topic, which, children, is binomial theorem, right? So here now we are discussing binomial theorem, right? And before we formally look up what a binomial theorem really looks like, which will help you in expanding any power of a binomial like x plus a raised to the power 7, or probably x plus a raised to the power 17, right? So we have a formula which now I'm going to discuss. But before that, I will give a quick recap to you people, so that all of this that I have discussed is well settled with you people. Now, when we are talking about binomial theorem, you got to remember that we first will be talking about an algebraic expression. An algebraic expression is the mix of alphabets which are representing the constants and the alphabets which represent the variables. The initial alphabets like A, B, C are considered to be constants, and the latter alphabets like X, Y, Z, etc., they are considered to be the variables. So such a sort of a mix that we have is an algebraic expression. Now, when the power of the variables is to the maximum 1, then the degree of the algebraic expression is 1. When the power of the algebraic expression in the variables is to the highest 2, then we call about the degree of the algebraic expression to be 2, right? Or in other words, quadratic. The earlier, when the degree was 1, is said to be linear, right? And similarly, we have cubic, biquadratic, etc. sort of algebraic expressions in accordance with the highest power of the variables to be 3, 4, and so on. Now, children, next is when we talk about a term, what exactly do we mean which has quintessential significance when we talk about algebraic expressions? Now, let's say we have an algebraic expression which does not have a plus sign or a minus sign in between, then that sort of an algebraic expression will be said to be a term, right? So here we get to see that there is no plus sign or minus sign in between. As such, this will be said to be a term. And whenever an algebraic expression just has one term, it is known as a monomial. If suppose there is one plus or minus sign in between, then we will have two terms now. As such, it will be known as a binomial. And if we talk about an algebraic expression which has two plus or minus signs in between, then obviously we will have one term. 2-term and 3-term, right? And that algebraic expression which has 3 terms will be known as a trinomial. If it has more than 3 terms, then it will be known as a polynomial, right? Now at the moment we are going to talk about binomials as such. Now we talk about certain binomials, for that matter certain binomial expansions that you've studied. So if say we talk about x plus a, which is raised to the power 2, we have studied that its value is x square plus a square plus 2xa, right, which is actually the square of a binomial, something like you must have studied probably a plus b whole square, which is equal to a square plus b square plus 2ab. Now here I have replaced a with x and a with b with a, right, which is more conventional, but probably you have learnt a plus b whole square. Now children, here when we talk about another formula that you studied, that is x plus a whole raised to the power 3, its value is also learnt by heart by you, that is x cube, that is the first term cube, plus the second term cube, that is a cube, plus 3xa times of x plus a. I'm sure you must have learned something like a plus b whole cube, which looks something like this. But if we ask you the value of an algebraic expression which is a binomial raised to something except 2 or 3, like 7 or probably 17 or probably 173, then what is going to be your answer? In order to find that, we talk about studying this topic, which is binomial theorem. So now children, I'm going to spill the beans over binomial theorem, and I'm going to tell you what binomial theorem actually looks like. So if say we talk about binomial theorem, we will be having something like x plus a, which has been raised to the power n. Remember here, when we are talking about this n is actually from the set of natural numbers for initial discussion. Later in times to come, we will be changing the value of n to be from the set of rational numbers, but that is later in the study of binomial theorem. So now when we talk about x plus a raised to the power n, you've got to remember that if we talk about x plus a as we have 1 plus sign, or it can even be replaced by a minus sign, we actually have the sum or the difference of 2 terms. And as it has 2 terms, that is the algebraic expression has 2 terms, we will call this to be a binomial. And since this is a general power n whose value can be kept from the set of natural numbers, we call the value of this general expression to be the binomial theorem. So next now children, we will be discussing what the binomial theorem looks like. So further now we write the expression for this. That is, first now we write a binomial coefficient, which in times to come I'm going to discuss. So first we write n in the superfix, then we write a capital C, and we write a 0 in the suffix. Further, we write the first variable, that is x, or the first term, which is x, and we write its index to be the difference of the superfix and the suffix, that is n minus 0. And after that we write the second term, which is a, and we raise its power to be the same as the suffix, which is 0. Now children, to that we add here nc1, which is the next binomial coefficient, and we multiply it with x, which is again raised to the power the difference of the superfix and the suffix. And after that we talk about writing the next term, which is a, and we raise its power to be the number which is there in the suffix, that is 1. And then after that we talk about the next term, which obviously I'm sure you are able to assume now is going to be nc2, and now we raise to the power of the first term to be the difference of the superfix and the suffix, the second term raised to the power the number which is in the suffix, and all of that children is going to continue up to the last term, which is ncn, the binomial coefficients, that is n to be there in the superfix as well as in the suffix. And then we have the power of x, which is again the difference of the superfix and the suffix, that is n minus n, which in the next step is going to become equal to 0. And further this is multiplied with the second term, that is a, raised to the power the number which is there in the suffix, right? So this children is the binomial expansion. Now in times to come we will be discussing this further in detail, but at the moment I'll just quickly discuss this once once more so that all that I told you is perfectly clear. So here, children, we have x plus a raised to the power n, and that is equal to nc0, x raised to the power n minus 0, a raised to the power 0. You can learn it this way, that whenever we have a binomial which is raised to a natural number power, we talk about the binomial coefficients starting from nc0 and we proceed to nc1, then we go to nc2, and the last is ncn. Right? For that matter, you can see one thing more, that whenever we count from 1 to 10, obviously we will be having 10 different numbers. If we count from 1 to 98, we will have 98 numbers. But if we start counting from 0 to 10, we will have 11 numbers. Similarly, if we count from 0 to say 74, we will have 75 numbers. Now, if we count from 0 to n, we will thus have n plus 1 terms. And this shows you that whenever we have a binomial expansion which is raised to some natural number power, the number of terms are n plus 1. Further, if we now talk about the value of these binomial coefficients, so now we're going to discuss how we can find out the value of the binomial coefficients. For that matter, let us now say that we have some 4c say 2. If you want to find out the value of this, we can now write this to be factorial 4, which is going to be divided by the difference of the superfix and the suffix factorial and the factorial of the number in the suffix. Now, children, what do you understand by factorial? For that matter, let us say now we have factorial 7, and then we will write this to be 7 to be multiplied with the next natural number, which is less. Then we will multiply this with the next less natural number, that is 5, and all of that, children, is going to continue up to 1. So I'm sure if you want to find out factorial of 23, very easily you can do it by multiplying 23 with the number which is just adjacent to it and also less in the natural numbers, and that is going to be 22. And further, we will have similarly into 21, and children, all of this is going to continue up to 1. So this is how we find out the factorial, right? After this, in the next step, what we're going to do is we can now write this factorial 4, right, which is going to be 4 into 3, right, into 2 into 1, and then we divide this by factorial of 4 minus 2, that is going to become equal to 2 factorial, that is just 2 into 1, and then we have further multiplied this with factorial 2, which is again 2 into 1. Remember, 1, children, wherever it is not going to bring any difference because 1 is a multiplicative identity. Now 2 into 2 is going to become equal to 4, which will get cancelled with the 4 in the numerator, and then you will just have left out with 6. So this is how you find out the value of a binomial coefficient. Remember, whenever you find out the value of a binomial coefficient, it again comes out to be from the set of natural numbers. So let's quickly look up another example. For that matter, if suppose we talk about a binomial which say is some 17c4, then obviously this is going to become equal to factorial of the number which is in the superfix divided by the factorial of the number which is the difference of the superfix and the suffix, that is 17 minus 4, and in the denominator also you have the factorial of the number which is then the suffix. So as such, children, this is going to become equal to factorial 17, which is now going to be divided by factorial of 13 multiplied by factorial of 4. So again, we can calculate this. So this can be written as 17 into 16 into 15 multiplied by 14, and further it will be multiplied by factorial 13, because factorial 13 will be having numbers from 13 into 12 into 11 and so on up to 1, right? Further, now in the denominator we have factorial 13, which is going to get cancelled with this factorial 13, right? And except that we also have factorial 4, which can be written as 4 into 3 into 2 into 1, right? Now, children, we get to see that we can now have 4 cancelled with 16 4 times, and except that we can cancel 3 with 15 5 times, and further 2 can be cancelled off with 4 two times. As such, now we will be left out with 17 into 2 into 5 into 14, right, which is going to become the value of 17C4. I'm leaving it to you people to calculate this, but one thing that you've seen here is this is going to come to be from the set of natural numbers. So whenever you have a binomial coefficient, you got to remember that the binomial coefficient always is from the set of natural numbers. So here, children, now next what we do is we now have x plus a raised to the power n that we were talking about, right? And as you looked up, we first will be having a binomial coefficient, and then after that the first term is going to be raised to the power the difference of the number which is there in the superfix and the suffix, right? That is x raised to the power n minus 0. The second term is going to be raised to the number which is there in the suffix, that is 0. Right, then we come to the next term, which is again going to be nc1, the binomial coefficient, and then we talk about the first term raised to the difference of the numbers which are there in the superfix and the suffix, that is n minus 1, and the second term raised to the number which is there in the suffix, that is 1. And children, all of this is going to continue up to n terms, right, where we will have now the different binomial coefficients which will be multiplied with the first term and the second term, right? And as this is going to happen n times, right, from nc0, right, so the total number of terms that we're going to have will be n plus 1 terms, right? So the last term, children, is going to be ncn x raised to the power the difference of the numbers in the superfix and the suffix, that is x raised to the power 0, and as any number raised to the power 0 is 1, so this is going to vanish as 1 is multiplicative identity, and then further it will be multiplied with a raised to the power n, that is the number which is there in the suffix, right? So this is how we expand a binomial. So now let's quickly look up the example of expanding a binomial, right, by the formula of the binomial theorem once more. So I just explained to you people how we talk about expanding a binomial expression. Now after this, children, now next we're going to quickly look up how to find out the binomial coefficients one more time. That is, if you talk about 4c2, right, then we talk about writing 4 factorial, that is the factorial of the number which is there in the superfix, divided by the factorial of the number which is the difference of the numbers in the superfix and suffix, further multiplied with the factorial of the number which is there in the suffix, right? And then we require to calculate this. For that, I told you that whenever we have factorial of 7, say, then that is going to become equal to 7 into 6 into 5, and all of that, children, is going to continue up to 1, right? So similarly, children, if we talk about factorial 23, it is going to start off from 23 and it will go on up to 22, 21, and all of that further up to 1, right? So this is how, children, we calculate the factorial. So if we have factorial of 4 divided by factorial of 4 minus 2 times the factorial of 2, right, we can write that to be 4 into 3 into 2 into 1 divided by factorial of 2, that is 4 minus 2, that is 2 into 1, and then further again factorial of 2, that is 2 into 1, right? So here we have the simplification of this, and when you simplify this, you will always find that this will come to be from the set of natural numbers. For that matter, we considered a crooked case also, that is 17c4. So that is going to be equal to the ratio of the factorial of the number in the superfix divided by the factorial of the number which is there in the which is the difference of the numbers in the superfix and the suffix, that is factorial of 17 minus 4, right? And further we multiply it also with the factorial of the number in the suffix, that is 4. Now factorial of 17 minus 4 is going to become equal to factorial 13. So we can write factorial 17 in the form of factorial 13 as 17 into 16 into 15 into 14 and further so on up to further factorial 13, because factorial 13 will start off from 13 into 12 and go on up to 1, right? And all of this multiplied will actually give you factorial 17. Now factorial 13 will get cancelled. So further you will have 4 into 3 into 2 into 1, which is factorial 4, which can be easily cancelled off with 16 and 15. 4 4s are 16, and then 2 will get cancelled with 4 2 times, 3 will get cancelled with 15 5 times, and further then, children, we require to multiply all of this to be able to get to the value of factorial rather binomial coefficient 17C4, right, which is the ratio of these factorials. As you see, this is actually a product of natural numbers, thus this will also come to be from the set of natural numbers. So this is, children, how we write the binomial theorem. Further now we will come to certain questions. So I have now a question for you people, which now we are going to discuss, but as this now is perfectly clear, so I'd like you people to firstly give it a try, and after that we will be discussing the sum. So I'll give you some 10 seconds for trial, after which we will be discussing the sum. 1, 2, okay guys, now let's discuss the sum. In the question you've been asked to expand 3x minus 7 upon y square whole raised to the power 6, right? So if you talk about this expansion, as we see that this is something like a binomial that we studied, so as such now we will write the formula which explains the expansion of a binomial. That is, if we have some x plus a raised to the power n, then that is going to become equal to nc0, the first term raised to the difference of the superfix and the suffix, that is n minus 0, and the second term a raised to the power number which is there in the suffix, that is 0. To that then we add nc1, which is the next binomial coefficient, multiplied with x, that is the first term, raised to the power the difference of the numbers in the superfix and the suffix, and further the next term a raised to the power the number which is there in the suffix, that is 1, and all of this, children, continues up to the last term, which is going to be ncn, right? Then we have the first term raised to the power the difference of the numbers in the superfix and the suffix, that is n minus n, and the second term a raised to the power number which is in the suffix, that is n, right? So this is how, children, we expand a binomial generally. Now we will call upon this formula to expand this specific case. So we now have 3x minus 7 upon y square, right, which is going to be raised to the power 6, and we've got to expand this. So the first term is going to be written as 6c0 3x, which is the first term raised to the power the difference of the superfix and the suffix, that is 6 minus 0, times of minus 7 upon y square, which is going to be raised to the power the number which is there in the suffix, that is 0, and to that is going to be added the second term, which is 6c1 3x, that is the first term raised to the power the difference of the numbers which are there in the superfix and the suffix, times of minus 7 upon y square, the second term raised to the power the number which is there in the suffix, that is 1, and to that, children, we're going to now add 6c2 3x, that is the first term raised to the power the difference of the numbers in the superfix and the suffix, that is 6 minus 2, and the second term which is minus 7 upon y square raised to the power the number which is then the suffix, that is 2. Further, we now have 6c3, right, 3x raised to the power the difference of the numbers in the superfix and the suffix, that is 6 minus 3, raised to the power minus 7 upon y square, which is raised to the power the number which is there in the suffix, that is 3. Next, children, it is going to be 6c4 3x raised to the power 6 minus 4 minus 7 upon y square raised to the power 4, right? And then after this we have two terms next now. So next, I'd like you people to quickly tell me what the next term is going to be. I'm going to write, and before I write, just try telling. Very good. Now the last one, we will all write it together. That is 6c6 3x raised to the power 6 minus 6 times of minus 7 upon y square whole raised to the power 6, right? Now, children, our task is to simplify and to get to the final answer. So first, children, what we're going to do is first we'll be finding out all of these binomial coefficients. So now, talking about the first binomial coefficient, we have 6c0. So obviously that becomes equal to factorial 6 divided by 6 minus 0 factorial times of 0 factorial. So this is going to become equal to factorial 6 divided by 6 minus 0 is 6 factorial, and 0 factorial, children, is 1. You got to remember this as a rule. That is, whenever you talk about factorial 0, then that becomes equal to 1. For that matter, always remember the factorial of a negative number is 0. Right? And that's why whenever we find out the difference, it is always from the superfix we subtract the suffix, and this also gives you an idea that the superfix is always going to be greater than the suffix, right? So these are the two formulae that you require to learn. Now after this, children, next 6 factorial will get cancelled. As such, we will get the first binomial coefficient, that is 6c0, to be 1. Now after this, we now talk about the next, that is, when we talk about 6c1, then that is going to become equal to factorial 6, which is going to be divided by factorial of 6 minus 1 times of factorial 1. Now this, children, can be written as 6 times of factorial 5 divided by factorial 5 times of factorial 1 is 1, so there is no point writing it. So you here find that factorial 5 will get cancelled, and this will thus come to 6. Next, now after this, we talk about 6c2, and that, children, is going to come to factorial of 6 divided by factorial of 6 minus 2 times of factorial 2. So further, this becomes equal to factorial 6 divided by factorial of 4 times of factorial of 2. So this can further be written as 6 into 5 times of factorial of 4, which is divided by factorial of 4 and multiplied by 2 into 1. So there's no point writing 1 because 1 is multiplicative identity. So at this moment I'm writing it, but from the next time onwards it can be understood that there is no significance of this 1 in multiplication. Now factorial 4 will get cancelled. As such, 2 getting cancelled with 6 3 times. So now we have the value of this to be equal to 15. Right now, children, remember that if we talk about the binomial coefficients, there is another rule which will help you quite a lot. That is, if you talk about the binomial coefficients from the beginning, right, they are equal to the binomial coefficients from the end. That is, the first one is going to be equal to the last one. Similarly, if you talk about the second one, it is going to be equal to the second last one. Here we are just talking about the binomial coefficients, remember, right? Next, after that, if suppose we talk about the next binomial coefficient, that is the third binomial coefficient, it is going to be equal to the third last, right? That is this one. And then if we talk about now the fourth one, obviously the fourth one comes out to be separate as there is no fourth last, right? So the last binomial coefficient that we should be finding out is 6c3. For that matter, at the moment, the ones which are equal, we can easily write them to be the other. That is, further now, 6c0 that we looked up just now is going to be equal to 6c6, right? And similarly, if we talk about the ones which have been marked by 2 asterisks, that is 6c1 is equal to 6c5. So further we have 6c5 to which this is equal to, and then if we talk about 6c2, as we found out the ticked ones, that is 6c2 is equal to 6c4, right? So both of these are equal. As such, we won't require to calculate these binomial coefficients. Next, now, children, we will quickly calculate the value of 6c3, right? So if we talk about 6c3, so 6c3 can be found out by writing factorial 6 divided by factorial 3 times of factorial 3. Now further, this can be written as 6 into 5 into 4 multiplied by factorial 3, and in the denominator we have factorial 3 into factorial 3. So factorial 3 obviously gets cancelled from the numerator and from the denominator, so we are just left out with 6 into 5 into 4, which requires to be divided by 3 into 2, which is factorial 3. Now 3 into 2 again gets cancelled with 6, so we are just left out with 20, which is the value of 6c3. Now that we have these binomial coefficients, so we can easily write the expansion of this binomial. So further in the next step, now first we talk about, remember, 6c0, right? So value of 6c0 is 1 times, so we will have 3x raised to the power 6. So 1 which is multiplied with 3x raised to the power 6. Now to that, now we are going to add the next term. Remember, here in the next term, what have we? We have minus 7 upon y square raised to the power 1. That means this term comes once, multiplied with the rest of the positive terms. As such, this term will become negative. So as such, now we will have minus times of the product of all of this, right? And as you see that we've already found out the value of 6c1 to be here 6, so this value requires to be kept next. As such, next now we have minus 6, which gets multiplied with 3x raised to the power 5, right? And further, that is multiplied with 7 upon y square, as the minus sign has already been taken outside. Now next, children, the next term is going to be positive, and here then we will keep the value of the next binomial coefficient, that is, we'll talk about 6c2. So 6c2, children, has come equal to 15. So we will now keep the value of the next binomial coefficient to be multiplied with 3x raised to the power 4, and to be multiplied with 7 upon y square, remember, right, raised to the power 2, because the power was the sign was minus, so when it got squared, then obviously minus into minus will become equal to plus. As such, we will just write the value of the binomial coefficient. We will write 3x raised to the power 4 and 7 upon y square raised to the power 2. Now after that, we will write the next term, which will first have the binomial coefficient. So we call in 6c3, remember it came to be 20. So next now we will have minus 20, remember, because in the next term we will have minus 7 upon y square raised to the power 3, right? And that is the reason we will have a minus sign here. So we have minus 20, which is going to be multiplied with 3x raised to the power 3. Then we have 7 upon y square, which is going to be raised to the power 3. To that is going to be added the next term. Remember, this is going to be equal to the binomial coefficient just before, that is, the value of 6c4 is equal to the value of what? It is equal to the value of 6c2, right? If we talk about the value of 6c0, right, it will equal to 6c6, 6c1 is equal to 6c5, 6c2 is equal to 6c4. So now that we are talking about the next term, which is the fifth term, right, so it will have the binomial coefficient the same as 6c2, so that will become equal to 15, right? So we will now have 15 times of 3x, which is raised to the power 2, minus 7 upon y square, or rather we can directly write plus, because minus into minus is going to become equal to plus, as the power is 2 here. And then next, children, we are now going to write the next binomial coefficient, which is 6 times of 3x times of here, in place of writing the power of 7 upon y square to be 2, it actually should be 4, right? So we write it to be 4 here, right? And after that, next now we have minus 6 times of 3x times of 7 upon y square, whose power is how much? It is to be equal to 5. And lastly, now we have the binomial coefficient as 1 times of 3x raised to the power 0, and any number raised to the power 0 is 1, so you can just forget it. And then you have 7 upon y square, which is going to be raised to the power 6, right? Further, you don't require to simplify this, and this thus is going to become your final answer. So I'll just quickly discuss this once more. In the question here, we have been given to expand 3x minus 7 upon y square raised to the power 6. So like I have told you here, as the power is 6, the total number of terms will be 7. That is, the binomial coefficients are going to go from nc0 to nc6. As such, 6c6, as such, that is going to be 7 terms in number. Now, first we write the expansion like we looked up earlier, that is of x plus a raised to the power n. The formula, remember always to write the formula to get the full marks. Next now, after the formula, we talk about this case which has been given to us. So we write the value of n, which is 6. Then we write the first binomial coefficient to be 6c0, First term raised to the power the difference of the superfix and the suffix, second term raised to the power the number in the suffix, and similarly we write all of these terms. After writing all of these terms, we now require to find out the value of these binomial coefficients. For that matter, when we talk about the first binomial coefficient, remember it is going to be equal to the last binomial coefficient, that is 6c0 is going to be equal to 6c6. Then if we talk about the second binomial coefficient 6c1, it is going to be equal to the second last, that is 6c5. Similarly, the third one is going to be equal to the third last one, right? So 6c2 is going to be equal to 6c4, right? This is what you can follow in sums, which you'll be doing in times to come. So we now calculate these binomial coefficients, which I'm sure now they are child's play to you people. You keep their values. Don't forget to keep the value of these minus signs as they ought to come. When you talk about any number raised to the power 0, obviously that will become equal to 1. So obviously this minus sign is not to be brought up. But when we talk about this minus 7 upon y square raised to the power 1, obviously this will also mean that minus sign requires to be multiplied in this term, and that is the reason why in the second term we have a minus sign. Whenever we have minus 7 upon y square raised to the power 2, obviously minus into minus will become equal to plus. As such, this term will have a plus sign, and this concept is going to be applied to all of these terms. And thus, if you write the answer in this form without finally calculating, as the calculation is too gruesome, right, you can get to your correct answer, and I'm sure the teacher is going to give you full marks. Right? So that is all that I have for you people in this lecture. Hope you people have got the basic grip of what binomial theorem is, and in times to come, when you follow the rest of the lectures, you will have got a very good strength in binomial theorem, right? So make sure to study all of this and practice all of these sums, right? Also remember my caution, how you go to study the lectures. When there is something which is being discussed, make sure to sit straight without a copy open or a book open and no pen in your hand. So you will be focusing completely then all that is being told. And remember, when you sit in a secluded place where there is no disturbance of a TV, mobile, or some family members trying to disturb you, then you will be able to access most of the knowledge and make best of these lectures. Do also remember to practice all of the same sums once more, right? And that will further increase your strength in this topic. So bye children, and do practice, and let's get better in maths. Bye.